incline each other by an angle theta. The number of images formed is equal to 360 degrees over theta minus 1, where n is the number of images, theta is the angle of tilt. I don't know if you remember. So we'll look at rotation of a mirror. When a mirror is rotated through an angle theta, what happens? Rotation of a mirror. Rotation of a mirror. That's the next subtopic and light we'll be looking at, optics, geometric optics. So when a mirror is rotated, so there's a mirror. The source of light is here. So this is the source of light. It can be a bulb or whatever. So this is the source. If the mirror is like this, and then the source is switched on, we have a ray of light incidenting on the mirror. Let's draw a normal. Once there is an incidence, we'll talk about angle of incidence and angle of reflection. So let's draw a normal. So this is N1. Now, if we have a screen here, this is a screen. The screen is something which captures an image. So when the light hits on the mirror, it can reflect. This is the angle of incidence, I. And so there's the angle of reflection. I think R is greater than I. So this is R. You let me get rid of the screen first. Now from our laws, angle of incidence equals angle of reflection. So if this is I, this is also I. Of course, that is R, but because angle of incidence equals angle of reflection, if this is I, this will also be I. Meaning if this is 30, this will also be 30. Ishra and Janice, are you okay?
Yes, please.
Now, if we rotate this mirror, so what we are doing is that we are assuming this is the mirror. If it is not rotated and you incident light on it, this will be the reflection. Now, when I rotate it through an angle theta, and I've done that, the ruler now is tilted. What happens? That is what we are going to investigate. So we want to rotate the mirror by an angle theta. It's the same mirror. It's the same mirror. but this time we are turning it. So when you rotate the mirror by an angle theta, so the mirror's old position and then the mirror's new position, the angle between is theta. So when we rotate the mirror through an angle theta, what happens? Now, in rotation of the mirror, if this is the old mirror, the marker indicates the old mirror position. This is the normal N1 to the old mirror. So the mirror, the old mirror position, and then its associated normal. When I rotate it through an angle theta, and I'm rotating the mirror through the angle theta, that's what is happening. As I rotate the mirror through an angle theta, guess what is happening? So this is a new mirror position. What has just happened? Is there any observation? I take it again. This is the mirror's first position. It is here. When it is not rotated. Now, when this is the normal N1, I'm going to rotate the mirror through an angle theta to a new mirror position. Is that what is happening today? What is happening as I rotate the mirror? Any observation? Israel, you there? Or you are gone? Janice? Israel, you are here. Hello, Israel. Hello. Janice, can you hear me?
Yes, please.
Okay. Watch and then make a contribution for me. This is the mirror position when it is not rotated. When it is not rotated, this is the mirror position. This is the normal. This is the normal to the mirror. As I rotate the mirror through an angle theta, what is happening? What do you see to be happening as I rotate the mirror? Do you see anything? Janice, do you see anything? Hello, Janice.
So, Mr. Yeah.
Do you see anything?
Right. The normal position of the mirror changed.
The normal position changes. So I'm taking it again. This is the mirror, old position of the mirror. This is the normal N1. So as I rotate the mirror through an angle theta, you realize that the normal position also changes. So the point is that when you rotate it by an angle theta, the normal would also change from its original position, its first position, by the same angle. So when you rotate it by 15 degrees, the angle between the new normal and then the old normal would also be 15 degrees. Are you clear?
Yes, please.
All right. So we are not changing the direction of the incident light. It's still here. The normal is always perpendicular to the mirror. So N1 is perpendicular to mirror position 1. We have mirror position 2. We need to have a normal to it. And the normal must also be perpendicular to the second mirror position. So this is N2. This is N2. The angle between the old normal and the new normal is equal to the angle of tilt. So theta. Okay. So if we are measuring the new angle of incident, it will be the angle between the incident ray and the new normal. Okay. Meaning there will be a new angle of refraction, which must also be equal to this magnitude. So let's assume Janice and Ishra, please give me a minute. I'm coming in.
It's okay.
I'll be with Ishra and Janice. Is that point okay?
Yes, please.
So N2OR2 must be equal to IO2 N2 because angle of incidence equals angle of reflection. So we are saying this is I plus theta. Then this must also be I plus theta. The point is that we need the angle between the two reflected rays. When mirror is not rotated, its reflection is R1. When it is rotated, its reflection is R2. We need this small angle between this. Okay. But the good thing is that we know N2O R2, which is I plus theta. Meaning that if we could determine the small angle, we just subtract it from this bigger angle. Then we have this. We are looking for this. We have this bigger one, N2OR2. So if we could get this and subtract it from the bigger one, then we could get angle R1OR2. So the angle R1OR2 is equal to the bigger picture N2OR2 angle N2OR2 minus the small one N2OR1 angle N2OR1. So our big question is that how do we determine this to subtract it from it? Because N2OR2 is I plus theta. Okay, how do we determine this in order to subtract it from this one? Any idea? Any idea as in how we can get angle N2OR1? Ishra and Janice. Any idea? Ishra, any idea as to how to go about that? Janice, any idea?
No, please.
Insra, any idea? Hello, Insra. Okay. Then look here. You see angle N1 OR1. Janice, what is the angle there? Angle N1 OR1. N1 OR1. What is the angle there?
Please, teacher.
No, theta is the angle between the two normals. I told you that when we saw that when you rotate the mirror by theta, the normal also rotates by the same margin. So we are talking about this angle N1 OR1, which is this whole angle. Okay, that is what I'm asking for. It's about this whole angle. This angle is the old angle of reflection. The old angle of reflection is incidence is ION1, and R1 is a reflection of R. The one represents when we haven't rotated the mirror, and then the two represent when we have rotated the mirror. Yanis, are you okay?
Yes, please.
So this angle N1 OR1 is the old angle of reflection. The old angle of reflection. This is the old angle of reflection. So if the old angle of incidence is I, Janice, what will be the old angle of reflection? That will also be what? I, because angle of incidence equals angle of reflection. So this whole angle N1 OR1 is I. Now the angle between the two normals, when rotated and when not rotated, is theta. So what do you think will be this small angle N2 OR1? What will be angle N2 OR1? Can you think through and then give an opinion? Janice, I'm doing this with you. Inshra wouldn't talk. So
I plus teacher.
you are close, but you see, N2, N1 OR1 is made up of two angles. Okay, angle N1 ON2 plus angle N2 OR1. So look at it. Angle N1 OR1, N1 OR1 is equal to angle N1 ON2, N1 ON2 plus angle N2 OR1, N2 OR1. Yes. So if angle N1 OR1 is SI, and angle N1 ON2. Janice, what is angle N1 ON2? What's that angle?
I.
No, watch closely. Is the angle between the two normals. Angle N1 N2. What's the angle?
Theta.
Good, theta. So make angle N2 OR1 the subject. Make angle N2 OR1 the subject. N2 OR1 from here. That's equal to Janice, I'm listening. That's equal to
I plus theta.
no, open your eyes. That's what we have. You are making this the subject. So that will be equal to oh, you are making this the subject. So you have to take this from here.
I minus theta.
Go. So I minus theta. Okay. Good. So once we have this and we are looking for the angle R1 O R2. Okay. Angle R1. Where is it? Go, this one. Angle N2 O R2. You see, so we have this. Earlier we said that, oh, okay, angle R1 O R2, R1 O R2 would be equal to angle N2 O R2 minus angle N2 O R1. And we found this one. We found this. We found this. So we substitute it into the relation. Therefore, the angle between the two reflected rays R1 O R2 would be equal to N2 O R2, which is equal to this. So I plus theta minus, okay, minus N2 O R1, N2 O R1, which we found to be this. So I minus theta. All right, so we have all that we are looking for is the angle between the two reflected rays R1 O R2. So we have, let's open the brackets, and we have minus I plus theta. Therefore, I and I would reduce to 0, theta plus theta. So this is 2 theta. So angle R1 O R2 is equal to 2 times theta. The theory we are developing is that when you rotate a mirror through an angle theta, the angle between the first reflected ray and then the second reflected ray is equal to 2 times the angle of rotation. When you rotate a mirror through an angle theta, the angle between the first reflected ray and then the second reflected ray is equal to 2 times the angle of rotation. Meaning, when you rotate the mirror by an angle 10 degrees, the angle between R1 and R2 will be 2 times 10, which will be 20. Please, Janice, are you okay?
Yes, please.
Let me quickly go over for those who just joined. Akuya and Ohenawan and Kenneth, you are welcome.
Thank you, sir.
We are looking at rotation of the mirror. Let me clean it and then look at it once more. Because we started this when you were only 2, when I had 2 students. Obenewa, are you there?
Yes, please.
So we are looking at rotation of the mirror. Rotation of the mirror. Of the plane mirror. So that discussion is under plane mirror. The rotation of the mirror. So I have a mirror. I'm going to incident a ray. So I will need a normal. So N1. I have my incident ray. So source of light is here. Source. This is angle of incidence, I. And so its reflection. So this is the reflected ray. I'll call it R1. Angle of incidence equals angle of reflection. So that is also I. That is also I, because they have the same value. Now, I'm going to rotate the same mirror. So there's a mirror, the first mirror position M1. I'm going to rotate it through an angle theta, whether clockwise or anti-clockwise. So it's like this. When the mirror is like this, and then you rotate it through an angle theta, whether clockwise. Now, the question is that when you rotate it, we are not changing the angle of incidence, but will the reflected angle of reflection or the reflected ray vary? Will the reflected ray vary? Class, Kenneth and Co. Will the
Yes,
reflected
sir.
ray vary when you rotate it?
Yes, sir.
Go. It will vary because the normal must always be perpendicular to the surface. So when you rotate it through an angle theta, the normal position would also change. But how will it change? So I'm rotating this through an angle theta. So the same mirror, please, it is not a different mirror. So M2 is a new mirror position where it is rotated through an angle theta. Now, the normal position to the new position of the mirror will certainly change because the normal is always perpendicular to the surface of the plane. Okay, but open your eyes and watch something. If this is the mirror's old position, This other marker represents the normal to it. Okay, so I'm going to rotate the mirror through an angle theta. The horizontal marker represents the mirror's old position. The vertical marker represents the normal to the first position M1. Are we okay? So watch how when I rotate it through the angle, what will happen? So I'm rotating the mirror through an angle theta. Okay, I'm taking it again. The old position M1. When you rotate the mirror by an angle theta or through an angle theta, this is what happens. What is happening to? What is happening here? Yes, what is happening? Can somebody tell me what is happening? Yes, can somebody tell me what is happening when the mirror is rotated? Class, I want a feedback from. Pardon?
The position of the normal changes.
The position of the normal changes. But by what margin? By what margin? Yes, it is changing. This is the first position of the mirror. This is the normal. When you rotate it theta, the normal also rotates with the mirror. So if you rotate the mirror through an angle X, the normal would also rotate through X. Please, do you see it? Kenneth and Co, do you see it?
Yes, please.
So when Obenowa, do you see it? So the new normal, this is O, the point O. The new normal must also be perpendicular to the first position of the mirror. Sorry, the second position. So this is N2. But the angle between N1 and N2 is equal to the angle of rotation. If you rotate the mirror theta, this angle between N1 and N2 would also be theta. All right. Once there is a new normal, then it means with respect to the first mirror, the second mirror position, when it is rotated, this becomes the angle of incident with respect to the second normal. So the angle of incident with respect to the second normal when the mirror is rotated will be equal to I is incident ray to N1. Then this. So we have I plus theta becoming the second angle of incidence, because this is I and this is theta. So let me put I here. Angle I O N2. I O N2 is equal to I plus theta. Angle I O N2 equals I plus theta. It means that there will be a new reflected ray with respect to the second normal, and then the second position of the mirror. Class, I hope you are following.
Yes.
So, with respect to the second normal, the new angle of reflection would also be,
Mr. Adria,
hello,
please, is the incidence plus theta the incidence ray or
come again.
the incidence plus theta? Please, what is it?
This is I plus theta is the second angle of incidence after the mirror is rotated. So after rotating the mirror through an angle theta, the new angle of incidence is the old angle of incidence I plus the angle of rotation theta.
Okay, thank you.
So the new angle of incidence is this, which I'm calling as angle ION2. Angle ION2 is this whole angle. This is the new angle of incidence. So if the new angle of incidence is this, then what will be angle N2O R2? R2 is the second reflected ray after the mirror is rotated. What will be this angle, class? What will be angle N2 N2O R2? Yes,
I plus theta.
exactly. Because angle of incidence equals angle of reflection. So this will also be I plus theta. Okay. Now, when the mirror is rotated, we are only interested in the angle between the two reflected rays before rotation and after rotation. So our point of interest so much is what happens here. The angle R1 O R2. So we are interested in angle R1 O R2. That is our point of interest. Okay. Kenneth, are you there?
Yes, please.
Contribute and stop being an observer. Contribute, express your views. So this is what we are interested in. Now, we have this angle N2 OR2, which is I plus theta. We want this angle. It means that if we could find this angle, if we could find angle N2 OR1, okay, we just subtract it from the bigger picture to get this. So what we are looking for can be determined from this. The bigger angle of reflection there, the bigger angle of reflection, which is angle N2O R2, is equal to this small angle plus this angle. So this is equal to angle N2 OR1 plus angle R1 OR2. So if you are looking for this, then you must know this to subtract it from what you know. Therefore, angle R1 OR2 is equal to angle N2 OR2 minus angle N2 OR1. Okay, this we have an idea that is equal to this. So this is I plus theta, but we need this to subtract it from this to get what we are looking for, R1 or R2. So the question is that how do we determine angle N2O R1? Any idea? Any idea as to how to get this and subtract it from this one? Whilst you think through, what is angle N1O R1? What is
Mr.
angle?
Idra,
Uh-huh.
please adjust your camera to the top a bit. Thank you.
What is angle N1O R1? What is it?
Sir, please, I.
That is I. And so if we are looking for angle N1O R1, think through. It is clear. If you have seen that that is I, then think through, let's get N1O R1. Akuya,
I minus theta.
explain to us why.
Study please angle N1 O R1. O angle is I. So if you want just N2 O R1, you subtract theta to get theta from I to get the angle.
Exactly. Okay. So look at this bigger picture. N1O R1. That is I. So angle N1 O R1 is equal to, this is equal to angle N1 O N2 N1 O N2 plus angle N2 O R1 N2 O R1. Now you just saw that this is what we are looking for. So when you make N1, N2 O R1 the subject, N2 O good, angle N2 O R1 the subject. This is equal to angle N1 O R1 minus angle N1 O N2. We just saw that N1 O R1 is I minus N1 O N2 is theta. That's the angle between the two normals, theta. So it means that this small angle, angle N2 O R1 is this. Please, are we okay? Are we okay? Kenneth and Ko, are you okay? All right, so let's do the subtraction. Minus I minus theta. Nanama and Ayoko, Obenewa, are you fine?
Yes,
up to,
please.
up to where we have gotten to. So when we open the bracket, we have I plus theta minus I plus theta. I and I cancels out. And what is left is equal to 2 theta. Okay. And this is the angle between the first reflected ray and then the second reflected ray. Angle N1, R1, O, R2. What this simply means is that if you have a mirror and you rotate it by an angle theta, the angle between the initial reflected ray and then the final reflected ray after the rotation is simply equal to 2 times the angle of rotation. Theta is the angle of rotation. And we have come to the conclusion that, oh, then the angle between the reflected rays is twice the angle of rotation. Meaning, if you rotate a mirror by an angle x degrees, the angle between the two reflected rays is also 2 times x. That's the whole concept we are testing. Please, is that clear? Hello, is that clear?
Yes, please.
So, if the mirror is rotated 7 degrees, the angle between the reflected rays is also 2 times 7, 14. If you rotate the mirror 10 degrees, angle is 2 times 10, 20 in that order. Okay. So that's the point we are establishing. When a mirror is rotated through an angle x degrees, the reflected rays also rotates by 2 times x degrees, whether the rotation is clockwise or anti-clockwise. That's all. Please, any question? Any question? Let's see how we can apply this. How is it applied in solving problems? So under this, we are not changing the incident source of the incident ray. We don't change it because maybe we are using the sun, rays from a sun. Maybe we are using rays from a bulb. How do you change the incident ray? You cannot make any changes to the incident ray. So under rotation of a mirror, we keep the source of light fixed because of these reasons. Okay.
Stadia.
Hello.
Stadia, please, can you tilt it anti-clockwise?
Oh, yes, it can be clockwise or anti-clockwise. Whether clockwise or anti-clockwise, the same principle works. Okay. Okay. Hey, okay, we ask questions, and when I'm also demanding feedback from you, it's always a problem.
Yes, please.
So how do we apply this? There is a mirror. We have a screen here. We have a screen. Over here. A ray of light is incident on the mirror. The incident ray creates a spot on the screen. This is a screen. It creates a spot on the screen. So the reflected ray creates a first spot. A vertical spot 1. Then the mirror is rotated through an angle theta. So when we rotate, Kenneth, are you there?
Yes, please.
I ask you not to be quiet, be there and observing. Contribute. So if you rotate through the mirror, through an angle alpha, it creates another spot. It creates another spot. Spot 1, 2. The point is that after rotation, you have another reflected ray. So it creates another spot. Okay. Now you understand the principle of rotation, that when you tilt the mirror by an angle alpha, the angle between the reflected rays is twice alpha. So sometimes the application is that if you are given the distance between the mirror and then the screen as x, you can be, the possible questions is that you can be asked to calculate the distance between the two spots. So it's like knowing this, and then knowing 2 alpha, you can be asked to find the vertical height between the spots. That is a typical application of this. Please, are we okay? Are we okay?
Yes, sir.
So knowing the angle, knowing this distance, usually the two spots are the two reflected rays. There's the screen, and then the second create a certain right angle triangle. So if you have this and you are given the distance from the screen to the mirror, okay, this distance, you can easily find the spots, that the vertical height between the spots each when you have this. Or sometimes you can be given this angle, the angle between the two reflected rays is so and so, maybe 30 degrees. Create a determine the angle of rotation. Calculate the angle of rotation of the mirror. So it's like having been given the angle between the reflected rays. And you know the concept is that if the mirror is rotated through an angle alpha, okay, that angle of reflection must be twice that. So if this is 30, if this is 30 degrees, then certainly alpha will be equal to 30 degrees divided by 2, 15. So these are some of the applications and reflection of the mirror, rotation of the mirror. If you have any question, ask. Any question?
Mr. Adria,
Hello.
please, the 30 degrees that you have given, is that alpha?
No, that is the angle between the two reflected rays after it's been rotated.
Okay.
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 Alpha
Yes.
here is the angle of rotation. Okay.
Yes, please.
But the concept is that when you rotate a mirror through an angle alpha, the angle between the reflected rays would also be 2 times alpha. So if you have given me this as 30 degrees, then alpha must be 15, right?
Yes, please. Thank you.
Mhm. So these are some of the applications and the rotation of the mirror. Janice, are you okay?
Yes, please.
Hey, the late Immaculate. Obeno, are you okay?
Yes, please.
Okay. All right. Um, the next area. So this does it for plane mirrors. I'll look for questions and rotation of mirror and then send it to you in order to try your hands on. Now let's begin something under spherical mirrors. Spherical mirrors. Spherical mirrors. Give me a second, I'm coming. So with plane mirrors, we are looking at mirrors with flat surfaces. Flat mirrors with a surface flat. The reason for the name plane. Then we have some mirrors that are curved. The surface is curved. So they are also coated at one end. But such mirrors either curves inwardly. So if it's expected to curve inwardly, then the back is coated. The back is coated, meaning the reflected plane is this side. Then we have another one. The whole thing looks like this. If you have this side and then the side of it is coated. We have what we call as, this kind of mirror is called concave mirror. They are called concave or converging mirror. Then we have another one where the inner part is coated. This side. So this time around, the reflecting surface is here. And this kind of mirror we call this as convex mirror or divergent mirror. Okay. Now, how do we describe concave mirror or convergent mirror? We say in concave or convergent mirror, the reflected part curves inwardly where light is received and reflected, it is curved inwardly inside. So here the reflecting or the reflected parts of the mirror curves inwardly in concave or convergent mirrors. Then in convex or divergent, in convex or divergent mirrors, the reflected parts curves outwardly. The arrow indicates the reflected parts and it curves out. Here, it curves in. So this is, these are the two differences between convex and then concave. All right. Please, any question? If you have any question, ask. If you don't have any question, then we move on. All right. Now, why do we call concave mirrors converging and then convex mirrors diverging? Let me use ray diagram. if this is a convergent mirror. When you incident rays that are parallel, that are hitting the mirror in that parallel manner, these are rays, so the arrows. Convergent or concave mirrors have the ability to converge or bring to a common point all rays that are hitting it in that manner, in that parallel manner. So for a concave or convergent mirror, all parallel rays are brought to a common point. So all rays that are parallel are converged at one common point. The reason for which concave mirror is also known as converging mirrors. Then the other one, convex or diverging. This one curves inwardly. Sorry, outwardly. So when you incident rays that are parallel to the mirror, parallel rays are diverged. Rays hitting it in that manner are all diverged. Divergent rays. But diverged rays so with this kind of mirror, all diverged rays, all parallel rays are diverged. They spread out. Okay. So the reason for which we call this as convex or diverging mirrors. So concave or converging and convex or divergent mirrors. Please, if you have any question, quickly ask. If you have any question, ask. All right. Let's talk about uses of these spherical mirrors. Uses. Let's look at for concave or convergent mirrors. What are some of the uses of concave or convergent mirrors? Yes, give me your views. Give me your views, uses. Akuya, start.
They are used in torchlights as a reflector.
So it is used in torchlights as reflectors. So this is, let me show you one. Let me show you one. Look at this. Let me open it for you to see clearly. You see this curved part of the torchlight? Yes. This one curves inwardly. What you see as that shiny thing is a concave or converging mirror. Let me connect it and then on the torchlight for you to see clearly. So when it is there, a bulb is placed at the center. So when you on it, what happens is that it reflects, the rays hits the shiny part and it throws it. So it is used in torchlights as a reflector. Another, I've shown you one. Let your brain go embark on excursion to bring more. Uses of concave mirror. Yes.
Sir, please, in telescopes.
Yes, it is also used in telescopes as a reflector. It is used in telescope as a reflector. Again. Or the rest of you. Adjoa.
It's used in the headlight of cars.
Exactly. It is used in headlights of cars. Look at the headlights. That bulk lights at the side or in front of the car. You have concave or converging mirrors in there, which also does the same work as torchlight. So it is also used in headlights of cars. Any more?
They are used in floodlights.
It is also used in floodlights. Okay, at the stadia. Floodlights. Good. Do you have more? Headlights, okay. Searchlights and hunter's torchlights. All these lamps. All right. Let's look at convex. Please write them down. Convex mirrors. Convex mirrors or divergent mirrors. Immaculate, give us one. Your brain is in excursion. Immaculate.
Yes, sir, please. I've not thought of one yet.
Okay. Convex mirrors. Yes, who will start for us?
So please, it is used in side view mirrors of cars, in cars.
Okay. So the side view mirror, look at the cars. The mirror at the side, the driver's side mirrors are not plain mirror, neither are they concave mirrors. They are these mirrors. It curves inwardly like this. So they are used in side view mirror and head level mirrors in cars. And here there's a reason why this mirror is preferred over concave and plane mirror. So the convex mirror is used as side view and head level mirrors. Any more applications or usage?
Study, please, a question.
Okay.
The position is the head level mirrors.
Oh, the mirror at the top of the driver or at the head, okay, side or the head level of the driver, which the driver views through to look at the back. All right.
Yes.
Uses of convex or divergent mirrors.
Sir, please, sunglasses.
Sunglasses. Yes, yes. It is used to what? To diverge UV light so that UV light doesn't concentrate, but it's ultraviolet light from the sun. When it hits it, okay, it spreads it out. But that is not all. There is something within which also scatters it. But sometimes some glasses have that shiny surface and then it curves outwardly to reflect it. Any more?
So please,
Then
convex mirrors,
go ahead.
they are used in supermarkets and shops for security purposes.
Thank you. Absolutely. So, yes, those times where CCTV camera were not common. When you go to most supermarkets and shops, you see a mirror mounted at one corner of the shopping area. Okay, the mirror is convex because a convex mirror has wider area of viewing, of wider field view. So it is used as a for security purposes. Once it can enable the viewer to have a wider view of the shopping environment, somebody will just sit there and look through to monitor shoppers so that there wouldn't be pilferage of. So it is used in a shop for security purposes. More applications or usage.
So please, they're also mounted at curved roads for safety purposes.
Exactly. It is mounted at curvy roads where the road is curvy for safety purposes. And that is, this one enables you to have a wider view of your environment. So when a driver gets to such area of the road and it is mounted, by looking through, he can appreciate a better or have a better view of his back than plain and or the same converging mirrors. Do we have any more? Do we have any more? Adwa?
Mr. Asia, please, is it used in street lights?
Street lights. Oh, it is the other one, the concave mirror to reflect light from the bulb. Okay.
Yes.
It's similar to the floodlight situation we talked about. Have we exhausted the usage? Okay, yes, I think we have. Now let's understand why we prefer convex mirror for security purposes, while it is used in side view and head level mirrors than plane mirror and then concave. If you take an aperture of plane mirror, a light ray hits the extremes. This is an object. Rays would always come from the object. So when light ray hits one extreme and light ray hits the other extreme of the mirror, it will be reflected to obey. So for this aperture AB, this is the angle of view. So if somebody is viewing from here, this is the region, the area through which the person can have a maximum view. So this is the field of view, field of view. Then pick the same aperture for converging mirrors. AB. When light hits the extremes or the extremities of the mirror, this converges rays. So all the reflected rays will be brought to a common point. So for concave or converging mirror, this is the field of view, very, very small, or region of view, very, very, very small. This is it. Pick the same aperture for the same aperture for convex. Place an object in front of it. Light hitting the extremes. This will diverge rays. So look at the field of view. So you realize that among the three mirrors, convex or diverging mirrors would give you a wider field of view. That is the reason why this is used as side view mirror and head view mirror used in the shops for security at curvy roads, because when it is mounted there and then you view from it, you have a larger or a wider angle of view at your environment. So this would always give you a wider or a larger field of view. A major advantage over plane mirror and then concave mirrors. Convex mirror has a wider field of view. Class, is that okay?
Yes,
Yes.
sir.
So this is the reason why it is chosen for those functions. Side view mirror, head view mirror, um, for shops, used in the shops for security, and then in on our roads for safety purposes, because it produces a wider field of view. So that's it. Okay, I think we'll end here with the uses. Okay, I have to go to school 8:30 for prep extension. So we'll continue on Wednesday. Is that okay?
Yes, please.
Oh, no. Thank you so much. Bye-bye.